So what are acid-base reactions? Let's talk about those. Acid-base reactions always involve two things. So you're always going to get, as a product, a salt, which I'll talk about in a second, and water, okay? Basically, your acid and your base come together and they neutralize each other. Because again, think about what water is. Water is two hydrogen atoms and one oxygen atom. And from what we've learned about acids and bases, acids are compounds that, when dissolved in water, donate a hydrogen ion, an H+. Bases donate a hydroxide ion, or OH-. And so if you take hydroxide, OH, and add another H from the acid, now you have two H's plus an O. Guess what? That's water, H2O. So that's what we call neutralization. Acids and bases neutralize each other. The H from the acid mixes with the OH, and they just form neutral water with a neutral pH of 7. And we get this salt. So what is a salt? We know salt as HCl or sodium chloride, table salt. You put it on your food. It's yummy and all good things. But there are many types of salts. A salt is just a solid that forms when two liquids are mixed or two aqueous solutions are mixed together. It's just part of the reaction that happens. And this happens during acid-base reactions. So let's see how this works. Hydrogen chloride, which is a strong acid, and sodium hydroxide, which is a strong base. Two classic acids and bases. These react together, and out of this you get sodium chloride, which is your salt, NaCl, and your water. Now let's see how the salt forms. Well, the chlorine from the acid hooks up with the sodium from the base. So kind of the leftover pieces of the acid and base come together to form the salt. It's one way you could look at it. And of course, the OH and the H come together to form the water. Now you might be thinking, wait a minute, Mr. Ling, this is also a double replacement reaction too. And kudos to you if you noticed that. If you notice that the chlorine has switched places, basically, it went from the H to the sodium, right? And the sodium has kicked off the OH, and it's hooked up with the chlorine. And you can say that the OH and the H have kind of swapped partners as well, and hooked up with each other. So it's kind of a double replacement reaction as well. All right, acids and bases. Last but not least, we have oxidation reduction reactions, or redox. Redox reactions is when, this is all about electrons. So it's when one substance loses one or more electrons and another substance gains one or more electrons. And there's a couple of sayings that you can use to remember which is which. Leo says Gur. Leo the lion says Gur is one, because this stands for lose electrons, oxidation. So if you lose electrons, you are oxidized. Gain electrons, reduction. That's where you get Leo and Gur. Some people like oil rig. Oil rig works too. Oxidation is losing electrons. Reduction is gaining electrons. So you can think of it that way too. You have two ways to remember. How to spot it. So anytime a pure element becomes part of a compound, when you see something like this down here, it's usually a metal, not always, but pretty much 90% of the time it's going to be a metal from group 1 or 2 in the periodic table, or a transition metal as well. But a metal like copper here reacts with oxygen, and this is a pure substance right here, right? So there's no other thing attached to it. It's not an ion, right? It's not, because if it was an ion, it would have a plus something or a minus something up here, meaning has an imbalance of protons and electrons. It's not an ion. It's got a 0 net charge, and it's by itself, right? Reacts with oxygen, which also happens to be by itself in this case. And what happens, though, to form this, right, if we remember from our periodic table, oxygen is in group 16, so it has 6 valence electrons. It really wants to have 8, right? So when it hooks up with copper here, copper has a couple of electrons to donate. So copper gives up 2, oxygen takes those 2, and this now becomes an ionic bond, but also oxygen has gained 2 electrons. So oxygen has gained, so oxygen was reduced. Copper here added some electrons. So it was, I said it backwards. Oxygen gained electrons, reduced. No, I said it right, sorry. Copper lost 2 electrons, so it lost electrons, it is oxidized. And oxygen likes to oxidize other things. That's where we get oxidation from. So again, anything you see that loses electrons is being oxidized. Anything that's gaining electrons is being reduced. And how to spot it? It is a pure substance on the left reacting. And a lot of times it's going to be reacting with oxygen too, just a hint. Also, these are single replacement reactions, or all single replacement reactions are redox reactions, because in all single replacement reactions, you have one standalone element, right, by itself. So it is gaining or losing electrons in that process. All right, I think that's it. Any questions on this stuff, you know where to find me. All this is in your lesson as well, but hope this was a little bit helpful for you.